Good morning, dear students. Today I am going to teach you the creative part of organic chemistry. This creative is based on detection of alcohol, homologous series, the characteristics of homologous series and Grignard reagent, hydrolysis of Grignard reagent. So, let's start this creative question. Students, look at the whiteboard. Here, methyl iodide is refluxed with magnesium metal in the presence of dry ether to produce compound B. Here, first you have to know what is compound B. Students, here actually methyl magnesium iodide is compound B, and methyl iodide reacts with aqueous solution of potassium hydroxide. You know that potassium combines with iodine to produce potassium iodide, and this iodine is replaced by hydroxyl group of potassium hydroxide to produce methyl alcohol or methanol. So, compound C is methanol, and methyl iodide is heated with sodium metal in the presence of dry ether to produce alkane. Here it is mentioned higher alkane. I mean, in the compound A, the number of carbon atoms will be more than the number of carbon atoms of methyl iodide. So, this is actually Wurtz reaction. So, in this case, the product will be ethane. Students, you know that in the Wurtz reaction, the carbon number will be double. Here, two methyl iodides will take part in the chemical reaction, and two iodide combines with two sodium metal to produce sodium iodide. But I need not write here sodium iodide. Actually, I would like to just display you the stem of this creative question. First, you have to understand this stem, then you have to study the questions given in the below. Identify the functional group of compound C and write the reactions. Boys and girls, you can understand easily compound C means methanol or methyl alcohol. So, here actually functional group of compound C, I mean functional group of methanol is hydroxyl group, alcoholic OH. So, I have to describe here the identification of alcohol, the identification of alcoholic group OH. So, students, we know that methanol reacts with sodium metal to produce sodium methoxide, and hydrogen gas with bubble. Students, this hydrogen gas itself is a fuel and it catches fire. So, by using flame we can get confirmation about the produced hydrogen gas, and we can identify the presence of alcoholic OH in the methyl alcohol. This is the first confirmation test. And again, methyl alcohol reacts with phosphorus pentachloride In this case, the OH of methyl alcohol is replaced by one chlorine atom to produce methyl chloride, and phosphorus combines with one oxygen atom and 3 chlorine atoms to form phosphorus oxychloride, and the remaining chlorine, students, already I have given here 4 chlorine atoms, so it can be understood easily. There is only one chlorine atom remain, which combines with this hydrogen atom to produce hydrogen chloride. And if I pass ammonia gas through the hydrogen chloride, then a white smoke of ammonium chloride is obtained. This white smoke confirms the presence of alcoholic OH in the methyl alcohol or methanol indirectly. Students, so in this question, first you have to identify by the reaction C compound is actually methyl alcohol, then you will get mark 1, and for the first experimental test you will get another one too, and the second experimental test you will get 1, 3. So you will get 3 marks. I mean, this question will be set in the exam as applicable question, question C. Then is compound A the homologue of the compound obtained by the hydrolysis of compound B of the stem? Analyze it. Students, look at the whiteboard. Here methyl iodide is refluxed with magnesium metal in the presence of dry ether to produce methyl magnesium iodide. You know that methyl magnesium iodide is an example of Grignard reagent, and here it is given in the question the hydrolysis of compound B, I mean methyl magnesium iodide reacts with water. Now you have to show what will be the product in the reaction between methyl magnesium iodide and water. Methyl magnesium iodide reacts with water. Students, I have written water as a partial structural formula, and here actually this hydrogen atom combines with CH3 group to produce CH4 methyl, and the remaining OH combines with magnesium iodide part to produce magnesium hydroxyiodide. This is byproduct, that's why we have no headache about the magnesium hydroxyiodide. So students, and compound A, if I write here methyl iodide and sodium metal, according to the step, I can say this reaction occurs in the presence of dry ether. Now, if I heat methyl iodide with sodium metal in the presence of dry ether. Those two iodide combines with two sodium metals to produce two sodium iodide, and this methyl group or two methyl groups combine together to produce ethane. It is stated that ethane contains two carbon atoms. I mean, ethane contains, the product contains double times of carbon atoms of the reactant, I mean methyl iodide. Now my question, ethane and methane are the homolog of same series. Students, you have to understand that what is homolog. Each of the member of a homologous series are known as homolog of each other. Here our concerned compounds are methane and ethane. Both of the compounds are formed by carbon and hydrogen atoms. So I can say both of the methane and ethane are actually hydrocarbon, and the compounds can be represented by a general formula, and that is CnH2n plus 2. Here, if I plug the value of n is 1, then it will be C1 H2 into 1 plus 2 is equal to CH4. And again, if I plug here 2 and is equal to 2, it will be C2 H2 into 2 plus 2 is equal to C2H6 or C3H3. So students, it can be understood easily. Both of the methane and ethane can be represented by a common formula, and they are the consecutive member of same homologous series, and the name of homologous series is alkane. Students, methane and ethane are the consecutive members of same homologous series because here the value of n is equal to 1 for methane and n is equal to 2 for ethane. Those are two consecutive digits also, and there is a difference of a methylene group bond CH2 bond. There is a difference of a methylene group between methane and ethane, and methane and ethane can be produced by a general formula, and it can be, both of the compounds can be produced by decarboxylation reaction. Students, you know that CH3 bond COONA, this is the sodium metal of fatty acid, is heated with soda lime, sodium hydroxide and calcium oxide. Then methane is produced here. This part will combine together to produce sodium. There are two sodium atoms, that's why it will be Na2, and there is one carbon atom, and there are 1, 2 and 3 oxygen atoms, that's why it will be Na2CO3, and this hydrogen combines with CH3 to produce CH4. Again, students, if I write here CH3 CH2 bond COO-NA, this is sodium propanoate. Sodium propanoate is heated with soda lime. Here again, this hydrogen atom combines with CH2 to produce CH3 bond CH3, and sodium carbonate is produced as byproduct. So students, I would like to summarize about the question number 2 again. Both of the methane and ethane are formed by carbon and hydrogen. I mean, they are hydrocarbon. Methane and ethane can be represented by a common formula, and both are the two consecutive members of a series, and that is known as alkane series. And there is a difference of a methylene group between methane and ethane, and they are arranged according to their increasing molecular mass, and both of the methane and ethane can be produced by a general formula, and that is decarboxylation reaction. You know that in the decarboxylation reaction, from the main reactant COO, I mean CO2 is deducted from the main reactant. That's why it is known as decarboxylation reaction. Students, this type of question is very important for your board exam, and I hope you have already learned about the homologous series and properties of homologous series, alcohol preparation from Grignard reagent, and the identification of alcohol, and you have already learned about the Wurtz reaction. So students, no more today, and goodbye.